My name is Juri Leino. Some of you might have seen me here on stage before. It seems to become a habit. I work for exist-jwt and for e-ediciones as well. This work that I'm presenting today is mostly under the umbrella of e-ediciones, but it runs on exist-jwt. I want to start by really talking in general about design-first approach when designing APIs. And then later on, I will also show you some code because I know some of you like that. Yeah, so design-first APIs. What is an API first? We need to, I think, set this straight first. An API is an advanced programming interface. So it's basically something that humans and machines can talk to each other, and machines can talk to machines, and humans can talk to humans. So it's a contract between a server and a client, and server and client with human and machine is there. Usually when we think about servers and clients, these are machines, but I think most of the time most of the time is spent when we are trying to communicating what the API actually does between humans. So it is really important that we reach out and find consensus there. So here is a short history of the effort that we humans made into describing APIs. And when I say APIs, it started for me with an attempt to describe an HTTP API. There's a lot more, but we'll come to this. So in 1997, something like WDL, Web Interface Definition Language, was published as a node, as a W3C node. And it never got from there. So it never got traction. So we can cross that out. That is no longer a thing. Interestingly, that was already in XML. And it does not look that much different from what we're using today. So I found it, when I was researching, quite funny. So next attempt was WSDL, used by SOAP clients, introduced in 2000 by IBM. And back then it was called Web Service Definition Language. The version 1.1 came a year afterwards. And version 2 then was actually a W3C standard. And then the name changed to Web Service Description Language. So here we already hear the describing instead of defining something. I think that is also a very important distinction to make, because we're not actually defining the API, but we're just describing it. Okay, next. Shortly after was WDL. Can I scroll in here? Because I have a lot of notes here on this one slide. The Web Application Description Language, introduced 2009 already. So we have advanced quite far by Sun Microsystems, handled to the W3C, but they never intended to make it a standard, ever. So then, 27, so shortly before that, actually, so my timeline is wrong here. OData should be up there. Microsoft tried to come up with a standard that everybody should use. A standard that I have only found now that I was researching this topic, which I found interesting, because when I saw who is using this, it's actually, you have it in Azure, you have it in Salesforce. So there's actually huge traction, but it seems to be almost unknown. So show of hands who have heard of OData before? 1, 2, 3, 4. Okay. So, okay. As expected here in this crowd, you know your standards. Okay. Open Data Protocol, it's called. So OData is just the short form. And it's actually, since 2014, it's an OASIS standard. And since 2016, ISO standard even. But then, in 2011, Swagger came around and introduced their description language, which was used only by smaller companies at the beginning, so it kind of flew under the radar until IBM started to market it, and that way it found more traction, and especially that was actually just built to to automate the documentation of a WordNick API. WordNick is just one website. And this is all how it started. And nowadays, so Swagger got traction, and its first disgruntled customers. So there was MuleSoft, I think, that wanted to use this to create new APIs from the bottom up and not describing existing ones, and then thought, okay, now we have to come up with our own stuff. And that is RAML. And at the same time, interestingly, 2013 around, also Postman came around and started to have collections. I'm putting it here sideways because I need it later on. So in 2013, you could just Postman. I don't know who has used Postman here. Okay, third, fourth, half, almost. Postman allows you to collect these API requests that you do for testing, and then afterwards you have these in a collection if you want, and then that is how you could end up in describing an API, yeah? If you do that. Is that a question? No. Okay. If you have a question, you can shout, right? I have enough time because I was busy doing another workshop all the time, so I couldn't really concentrate on this one, I'm afraid. So bear with me if it's not up to standard. So there was even more. So RAML come up. There was API Blueprint. So a lot of people tried to compete with Swagger with this small little thing that came up there, but they all failed. In 2016, I think, what was it? Yeah, 2016, Swagger decided to do something about this, even though the competitors like API Blueprint and RAML, they had actually more money behind them. They all did not get the traction, but under the umbrella of the Linux Foundation, OpenAPI was founded. So what was before Swagger now became OpenAPI. That what we all use nowadays. So at the same year, something else happened. Google had been using something called Stubby, I think, since 2001, and doing a completely different approach from describing an HTTP API by describing schemas, and therefore that way saying, okay, this is the message how it looked like, and then I expect this to become the query language, and not so much in describing an HTTP API with its roots and pattern matching. They, in 2016, showed, open sourced it as gRPC, and it's also known as protobuf, for those who know that one, and it's a way to describe an API. In that same sense, you could say GraphQL has now their own schema definition language that is also around 2016. Let me check. Is it? No, 2018. Since 2018, that is part. Yeah, and there's a new contender also coming up. There's async API that I found while researching, what I found really interesting here. And it shows that there is a lot of things happening, especially now. So interestingly, Postman collections and async API both try to be a meta standard. So they want to consume OpenAPI and gRPC and GraphQL and combine them. So in a Postman collection, you can have OpenAPI calls, gRPC calls, and GraphSQL SQL in one collection. And async API wants to standardize the description of all these. So they want to integrate these other standards into their standard. Async API is also under the Linux Foundation. I found it very interesting, and I also just telling you all this because I think it's important to know where we came from. So there was a lot of different XML-based standards With OData, it changed to JSON. And those newer ones, they use their complete own format. So it's neither JSON, it's more like code, I would say. I think it's important to say that this contract is just using a different language. And if we understand that language, we can build our own tools upon it. Okay. So these are all out. OData is still in there, interestingly. OpenAPI is still in there. Postman, Async API, gRPC, and GraphSQL. I will focus on OpenAPI, obviously, because the tool that I built, Roaster, is built upon OpenAPI, so it only understands this at the moment. And this is why I want to concentrate on this. So let's see. The usual way of coming, and this is where we came from, is implementation first. So when the WordNik website was built, code was implemented, and then in some way or another, we had some parts that we could then later use to generate documentation out of it. And this you could then use to implement clients, right? And then you find a problem, obviously, always. And then what do you do next? Now, likely you need to go to either fix the problem in the server or you have to go to fix it in the client. But you don't really know which one. Or it's competing. Like you could now start to argue. The people that are doing the server are saying, yeah, but you're doing it wrong. And the others say, you're doing it wrong. And the documentation is lossy already because whatever you have in your code, it will never have the entire feature spec of how you would want to describe an API. So there's sometimes examples are missing, or so you will not want to have all the things in your code cluttering up your code that you would want to have to describe an API in its entirety, I would say. So at least from the implementations I've seen, I only see that there's a subset of annotations that you do on your root handlers from where you would then generate your docs. This is what I've seen in practice. If there is complete set somewhere, please tell me. I would like to know. Raise your hand now. No? Okay. In contrast to that, design first. That is the approach that the Roaster library then took. And more out of, I was taken by surprise. But it turned out to be really really good approach. You design your API. So you go to a tool like there's tons of tooling to create open APIs, open API descriptions, and you let the tool help you create that your dream API first. And then the one that you really think you need and that you have thought through. Then, because there's tooling for that as well, you can validate that. You can know, okay, for sure, this is at least valid now. This crosses the formal definition, or it's that checkbox. And then you can implement your server and client, both of them at the same time. So it allows you to parallelize that process as well. And given good tooling, you can even speed up that process a lot by having this file first. Because there is already scaffolding code for a lot of programming languages, as we heard already yesterday. And so you will still find problems, right? There's still no way around that always. It's what we programmers tend to hate, but it's just the way it is. So now you have, okay, oh, interesting. The timing was wrong here. But so you can also find a problem already in the validation step. And then you know, okay, I did screw up in the description of the API already. And you can go immediately up and start working on design. And if you find a problem later on, you can either just fix the implementation if you find that you just did something wrong, which is also very common. But you can also, if you find a conceptual problem, go back to designing again, which I think helps a lot, because then now we entangle that process a little. And also, there's a separate of concerns, because when we change the API, what we also will do, we will bump the version. And it's also something that you have to do. So your API needs to be versioned, otherwise it's a lot of assumptions will not work out. So in the middle is obviously the version of the API itself, but then there's also the API description language that has also a version. And so the version of the API description language, so which open API spec are we using, is already reflected in the API code. So if you change that dependency, you will also change your API version. And that also obviously has then its, you will need to implement that in the API, in the client and the server. And, but your tools will also be affected by the version of the API description language. So the tools, and this is where I'm at here, I'm in the tools department, right? Because I've created a library that lets you run a server. So they're all dependent on each other. And the API that you use will then tell the client, can I talk to the server? And the server will know, can I talk to that client, or does he understand me or not? So it's really important to have this versioning part right. Because this will always happen at some point. And I learned it the hard way. So I'm creating a library, and then I'm implementing a feature. And then all of a sudden, I get a customer yelling at me that I broke their code. And I thought, like, well, how? Well, it turns out that if you're permissive and you let people use parts of the spec that you haven't implemented yet, and they find a way to use it still already, and then you implement it correctly, then all of a sudden their assumptions break. So, so there's a lot of potential breakage there. And this is just one story that I told you. And so they can obviously be everywhere. So it is very imperative to get that versioning right. And how do we signal that? Versioning the API, there's several approaches that I have seen in the wild. The most common one is the first one, where you have a prefix, yeah, /version1 or something. And then you know, okay, if I talk to that endpoint, then I will always get that. And you have also the ability to maintain that URL for eternity, if that's your kink. Yeah? There's also the approach to use it as subdomain, and then there's also one to do it in a version header. Does anybody know a API that does the versioning in a header? HTTP itself, interesting, yeah. Now, I was more thinking about GitHub API, actually, because they do that. And they also show that you don't have to use any normal versioning scheme there. So they use just the last published date. That's their version. So then they know, if you're using that header, then you are at that state, and maybe we can still deal with you, or we know what you could be doing wrong, and can reject your call. So this is the tool that we wrote, Roaster, and this I presented in 2021. There's plenty of improvements, but I don't want to bore you with them right now. I'm here to tell you that it's used in production by several people. Somebody are in the room even, and so far nobody said no, this doesn't work. Okay, so it is performant enough. It can be much more performant, but more on that later. And I'm here to tell that some of the shortcomings or things that we haven't done before are mitigated and are now part of a new tool called OAD, short for Open API Definition, I think. It should be description now that I think of it. Yeah, but it's definition here. Yeah, so it's demo time. I want to show you that new thing. How do I do that? That's a good question. Huh. How am I on time? Oh. So I do not have much time. Then this will be short. Let me just show you. Can I make this? So when you install to play around with Roaster, there's a small test application that we already use that you can even install from the repository, and that I use here also now to play around, and that is called Roasted. And we can now do that. And what? Actually, we can go. Do I have it here somewhere? I'm using all my time just for this. Oh. Okay, so I take something from the internet, so it's completely safe, right? And run it through OAD resolve, which does a magical thing as, maybe we should do resolve first. Let's, so I just put it in here, pet store .json for later. Okay. That's blind here. Wow. Validate. No. Okay. And I did something wrong. Yeah, I entered here. I need to log in. That's very unsafe. Please don't remember my password. So, this stupid thing. Don't you love it? Okay, now I can evaluate that. Eval. Yay, it's true. So it is, so this function or this new module that exports 4 different commands, convert, flatten, report, and it's 5, right? Convert, flatten, report, resolve, validate. Validate does only give you a true or false. If you then want to know what the problem is, you have to actually call OAD report. So it's used for something where you want to just check, is it valid or not? So for an automated check. OAD flatten uses process so that you can create components out of specifications that don't have components yet, and resolves all components and everything in a form that you can use it in Roaster already. And it can read YAML or JSON and combinations of YAML and JSON, and will just do the right thing. It understands at the moment 3.1, 3.2, and all the 3.0 versions, and 3.1 as well, but not 3.2, I think. It uses the Swagger parser library directly under the hood. So it's a Java module, and we will be using that was just actually a research project to get to a point where we can then use that to run Roaster itself. So let's do resolve. Yeah, but there is the resource. It's, oh, no, sorry. I have already the right. Okay. This eval. Okay, it's stored now in pets.json. Pets.json. You see now has the Open API. I can use that now to feed it to my roaster API, but I fear we don't have enough time. But then the thing that you have to do is handle API requests by implementing root handlers. Here I have some for you already. You can see this is, each of them is one root handler. And you can call them by saying to my root, this is handled by API.error triggered. And they are very short, as you can see. And even for file upload, let me see here. This is what's handling a file upload in exist-jwt. And it even checks, you can even check which file type you want to have. And it does multi-file upload as well. And I think it's kind of nice. Is that enough for a demo, or would you like to see more? Because I really have only 2 seconds left, so I'm out of time. Yeah, sorry. Never tried that. There's a future, as I told you, that is to use that. I want to use the Java implementation directly. We want to maintain the hackability, which has proven to be key in it. So I have built custom cookie handling on top of it, custom authorization functions, all because roaster itself is written in XQuery. So what we will definitely do is maintain that hackability by exposing all the functions that we currently have, like middleware and stuff, keep them in XQuery. Okay.
Thank you very much, Juri.